All right, I'm going to do my best to explain all the parts of the vectors pretty quickly. So the first thing is writing vector in composite form from 2 points. So let's say that they give me points A is 3, 2, and point B is 4, 7. And they say write the vector from A to B. All you're gonna do is you're gonna subtract the tail of the vector from the head of the vector. So this is the tail, this is the head. So we're gonna go 4 minus 3 is 1, and 7 minus 2 is 5. So that's it, and you use these to represent that it's a vector. If they ask me for the magnitude, it's the square root of this part squared plus this part squared. So the square root of 26 is the magnitude. So that's fairly simple. The next thing that they'll ask me to do is find the resultant vector. And they'll give me vector A and vector B. And then they'll tell me something like A plus B. So all I'm gonna do is add these two together, which gives me 7 and 11. If they told me A minus B, I would subtract them. So 3 minus 4 is -1, 4 minus 7 is -3. If they told me 3 times something, that just means I multiply the whole vector by 3. So 3 times 3 is 9, and 4 times 3 is 12. So that's fairly simple. If they ask me for resultant vector, if all it says is resultant vector, if that's all it says and it doesn't give me something like A plus B, A minus B, or whatever, that means that you're adding them together. So using those same ones, if it asks for the resultant vector, that would be 3 plus 4 is 7, and 4 plus 7 is 11. So that would be the resultant vector. If they ask me for the angle between the vectors, I'm going to show you what happened here. So I had a 3, 4 vector, and then I had a 4, 7 vector, and they want this angle right here. So first I found the resultant vector, which was, I just found that, this guy. I'm gonna do the tangent of theta, which is this guy right here, equals y over x. So of the resultant vector, the y is 11, and the x is 7. So then I have tangent of theta equals 11 over 7. So I'm going to do the inverse tangent to find theta. So inverse tangent of 11 over 7. And I'm just going to put that on my calculator. My calculator's not on. I hope it's, first I'm going to check, because I haven't used this one, that it's in degrees, and it's not, so good thing I checked. I'm going to put it in degrees. I don't want that radians because it's going to give me a decimal, and radians should be expressed in pi. So I'm going to do this. So the inverse tangent of 11 over 7 is approximately 57.5288 degrees. And that's the angle in between here that I found. If it asks me to find the magnitude, unfortunately this isn't a right triangle, so I can't just do this squared plus this squared and then square root it. I have to use the law of cosines. So the magnitude for this resultant vector, magnitude of this resultant vector is going to be a I'm going to use C to be the magnitude. C equals the square root of A squared plus B squared minus 2AB cosine of C. So that's the law of cosines. So the square root of this is still my A, so 7 squared, plus this is still my B, so 11 squared, minus 2 times 7 times 11 times the cosine of this angle that I just found, which is 57.5288. And I'm going to put that in my calculator. So square root 7 squared plus 11 squared minus 2 times 7 times 11 times the cosine of, I'm going to put my answer because that was what I had, and it gives me a magnitude of approximately 9.3446. So that's how I find that magnitude. Now, if they ask me for something like, what was the next section? Did resultant vectors, did angle between vectors? If they ask me for something like the work, no, let's do projection first. So the projection of vector B on A, that's how this would read. The projection of B on A. And they give me a vector B. I'm going to use the same ones where B was 4, 7, A was 3, 4. So what I'm going to do for this is the projection, I'm going to just put P equals, remember that it's B on A, dot product of B and A. Oh, I forgot to do dot product. I'll do that really fast. Let me do dot product. So dot product means that you have something like A and B, and I want to find the dot product, which looks like that, and it says dot product. I keep saying that, but I don't write it down. Dot product. You're just going to go this times this, which is 12, plus this times this, which is 28, equals 40. So that's the dot product. Okay, so I'm going to do dot product of B and A over the magnitude of B squared times the vector B. And so I'm gonna do all of this. So dot product of B and A I just found, which was 40. Magnitude of B I'm gonna do by doing the square root of 4 squared plus 7 squared, which is gonna be 16 plus 49. Square root of 65. So it's the square root of 65, because that's the magnitude, squared, times vector B, which is 4, 7. So 40 over, when I square this, it's just 65 times 4, 7. And I'm going to simplify this. This would be 8 over 13 times 4, 7. So 4 times 8 is 32 over 13. 7 times 8 is 56 over 13. So that's the projection of B on A. Then we have work. Work is equal to the magnitude of the force, which they give us, times the magnitude of the vector, which we'll probably have to find, times the cosine of theta. Now the only hard thing here is that this angle is the angle between the force and the movement. And so what I mean by that is, if I have something that's going up this hill and this is at 15 degrees, but it's being pulled at an angle of, let's say, 45 degrees, this angle right here is my theta, which is the difference between these two. So 45 minus 15 is 30. So that's the number that would go in here for cosine, okay? I think that's everything in the vectors. So I think that should cover you.